Number 12, which of the following reactions is not thermodynamically favored at low temperatures, but becomes favored as the temperature increases? So this is the whole delta G is equal to delta H minus T delta S. It is in the front of the packet given in the formula sheet. So we want something that would be thermodynamically favored at high temperature. So if you guys remember the whole idea of the thermochemistry here, something that is exothermic with increasing entropy is always thermodynamically favored. So we're talking about we're talking about a reaction that should depend on the temperature for the favorability. So I'm gonna go to the answer choices, and I will immediately get rid of C because that is exothermic with increasing entropy, and that should be always thermodynamically favored. And the other way around too. If something is endothermic with decreasing entropy, then no matter what the temperature is, this thing will always be thermodynamically not favored. So something that has endo with decreasing entropy, I'm going to get rid of it, which is going to be answer choice D. Endothermic with decreasing entropy, that's very big no-no. So we're between A and B, so I would just go ahead and try one or the other. So I already know the answer is B, so I'm going to go ahead and try choice A and show you why that's wrong. So we have, by the way, this is kilojoules and this is joules, so kind of match that nicely. I'll write this as negative. I'm trying choice A, by the way. 566,000. Once again, turning it into joules, and then per moles of reaction. I'm just going to not write the units out for the sake of time. Minus temperature. That temperature must be in Kelvin, so that's going to be positive. And that the delta S, that is negative 173. So think about it, guys. If you have a very high temperature here, well, that means, well, if you look at the signs, it's becoming a plus, right? So if you add more and more, well, the more likely that your delta G is going to go up and become positive, and that's a big fat no-no, because remember, when delta G is negative, when the Gibbs free energy is negative, that's the indicator that the reaction is thermodynamically favored. So given this, well, probably not answer choice A. Now, let me explain why then the answer choice B would make sense. So let's try those numbers now. So we have 484, so that's an endothermic, so that's not very nice for something to be thermodynamically favored, but minus the temperature is positive once again, and we have this positive 90. So take a look. That temperature right here, if this temperature were to go up and up and up, well, you're subtracting a bigger number, so like small number minus a big number, making it more likely that it will become negative. And that's a good thing because, once again, delta G being negative, the Gibbs free energy being negative, that is what indicates that the reaction is indeed thermodynamically favored. So that's why the answer choice must be B.